Hello, and welcome to the Physics Show. Today we are going to be talking about waves and the physics of baseball. Physics may seem boring, but it can be fun. For example, waves. There are three types of waves that travel through mediums: pulse waves, periodic waves, and sine waves. Pulse waves consist of a single traveling pulse in a wave. Periodic waves are waves of periodic motion, such as the motion of your hand moving up and down repeatedly. Sine waves are another type of periodic waves in which the wave moves in simple harmonic motion.
Ocean waves are often depicted as sine waves. A sine wave is a wave whose source vibrates with simple harmonic motion. The definition of simple harmonic motion is a vibration around an equilibrium position in which a restoring force is proportional to displacement. A sine wave is a special case of a periodic wave in which the periodic motion is simple harmonic. In this case, the ocean is at its equilibrium in the model because the water is calm and flat. Ocean waves are also longitudinal waves because the particles in the waves vibrate parallel to the direction the wave is traveling. Transverse waves are another form of moving particles, but unlike longitudinal waves, the transverse waves particles vibrate perpendicularly to the direction of the wave motion. Some examples of transverse waves are heat waves, radio waves, and light waves. There are many parts to a wave. The crest is the very top of the wave where the compressed regions are with the highest density and pressure. The trough, which is the very bottom, where the stretched regions of the wave can be found with the lowest density and pressure. The amplitude is the distance from the equilibrium to either the crest or the trough. Wavelength is represented by lambda. If you look at a diagram, you will see that one wavelength is when the wave starts at the equilibrium, moves up to the crest, moves down to the trough, and then back to the equilibrium point. The equation to find wavelength is wave speed divided by frequency. A sunset on the beach is a perfect example of waves and light refraction. Snell's law is a very important law when it comes to light refraction. Snell's law explains the relationship between the different angles of light as they pass from one transparent medium to another. In light refraction, there is a line called the normal line that is perpendicular to the water's surface. When light hits the water's surface at an incident angle, it alters the angle of incidence at the surface of the water. This alteration is called refraction. In the case of sun and waves, it is impossible for the sun to shine through the waves. Just like calm water, the sun refracts in waves as well. The water makes the incidence line bend, creating an angle of refraction to the normal line. When light passes from air into water, it's always bent toward a line drawn perpendicular to the air-water surface at the point of entry. The angle of refraction will be closer to the normal line than the angle of incidence because water is more dense than air. Why are sunrises red? When white light from the sun passes through the atmosphere, the higher frequencies are scattered by atmospheric particles while the lower frequencies pass through the atmosphere without changing direction. When the higher frequencies are scattered, it reflects blue, indigo, and violet, which are at the end of the spectrum. Because our eyes are more sensitive to light with blue frequencies, we view the skies as being blue in color. Meanwhile, the light that is not scattered is able to pass through our atmosphere and reach our eyes. The lower frequencies of sunlight, like red, orange, and yellow, reach our eyes as we look at the sun during midday. While sunlight consists of the entire range of frequencies of visible light, red, orange, yellow, green, blue, indigo, and violet, not all frequencies are equally intense. In fact, sunlight tends to be most rich with yellow light frequencies. For these reasons, the sun appears yellow during midday due to the direct passage of more amounts of yellow frequencies through our atmosphere and to our eyes. When light reflects off of small particles, it is called scattering. Rayleigh scattering is a type of scattering that occurs when the particles are smaller than the wavelength of the light being scattered. When the sun is lower in the sky, this effect from Rayleigh scattering is much greater. Much more of the blue light coming from the sun is scattered away from the direct path towards our eyes. Hence, the sun will appear very red when it is low in the sky. These molecules scattering light also cause the sun to appear redder than it really is. When the sun is high in the sky, the amount of reddening is small. However, the sun will still appear redder from the ground than from space because the atmosphere scatters some of the light.
Baseball is another fun way to learn about physics.
Take, for example, this baseball player.
Projectile motion is free fall with initial horizontal velocity. Therefore, the baseball player will throw the ball with an initial horizontal velocity, and the ball will travel in a curved path with gravity working as the only vertical force. When the baseball player is getting ready to throw the ball has potential energy because he has not thrown it yet. It is storing energy for when it will be thrown. When the boy winds up to throw the ball, he is moving in a negative direction of the equilibrium, creating more potential energy. When the pitcher releases the ball and it moves past the equilibrium in a positive direction, the ball has kinetic energy. Newton's second law states that an object will move with constant velocity until a force is exerted on it. The force at which the baseball hits the bat depends on the mass of the ball and how fast the speed of the ball changes. A pitched ball is going fastest when it leaves the pitcher's hand because air friction slows it down as it approaches the batter.
Free fall is the constant acceleration in this example. Free fall acceleration is the only vertical force acting on the ball. A falling object accelerates as it falls. Therefore, the ball will increasingly accelerate as it gets closer to the ground. In conclusion, free fall motion constantly accelerates. Newton's third law states that whenever one object exerts force on a second object, the second exerts an equal and opposite force on the first. When the ball hits the bat applies a force on the ball that equals that of the ball on the bat. Even though these forces are equal and opposite, there is a net force on the ball because the forces act on different bodies. Newton's third law states that for every action there is an equal and opposite reaction. In the case of baseball, a pitcher throws the ball in a horizontal motion. The horizontal force the ball is going against is the friction in the air. The ball pushes against the air with an equal amount of energy as the air pushes against the ball. The vertical force that the ball is fighting against is gravity, so gravity is pulling the ball down at an equal amount that the ball is pushing up. Baseball players can also use physics as a trick to hit the ball farther. Objects tend to vibrate at their natural frequency when disturbed. When traveling waves interfere with each other, they can form standing waves. Standing waves have alternating nodes and antinodes. Nodes on a standing wave are the regions where there is little to no amplitude, so there is no vibration. Batters want to hit the ball on the node of the bat, so there is little vibration and maximum energy is transmitted to the ball, thus causing it to travel farther. Momentum is another important aspect of physics that applies to pitching. The momentum of an object depends on both its speed and mass. When pitchers move their legs and hips first, that momentum is transmitted up the body, through the torso, and into the arms and fingers as they pitch the ball. If a pitcher tried throwing a ball just from the momentum of the fingers, it wouldn't go very far, because fingers have very little mass. The large mass of legs and hips creates the momentum needed to pitch a fast ball. Well, that concludes our fun learning lesson for today. Please join us next time when we discuss sound waves.